kind of depend on if the original equation has logs on one side only or both sides. If it is one side only, our strategy is going to be like we were doing on that last quiz, changing it to exponential form. But before you can change it to exponential form, that log has to be by itself. So when I'm looking at this, I have to get rid of the 5 first. And we have two options for that. One option, properties of logs, it would come up into the exponent. But the easier option, if you have 5 times something, what's the opposite of multiplying by 5? Okay, so we could divide by 5 on each side. So that gives us the log of x plus 3 equals 2. Now, if the log is only on one side, we can change it to exponential. If there's no base written, what is it assumed to be? 10. So to change it to exponential, it would be 10 to the second power equals x plus 3. Then we should be able to work this out. What is 10 to the second? Subtract over the 3, x is 97. You do need to do just a quick check at the end. Remember on logs, the argument has to be positive, so just make sure that it turns out to be a positive number. 97 plus 3 is positive, so we are good. You're just checking that you don't have a domain error. If it did give me a negative for my log, what would my answer be? No solution. So if you check it and it makes that argument negative, you just say no solution. Let's look at this one. Alright, so this time it's different because I have multiple logs over there. We still have to isolate the log. We can't use the definition unless there's just one log on that side. So I have a 3 in front. I can't just divide everything by 3 because I have more terms here. So what could you do with that 3? Well, if you divide it, you just have to put it over all of them. So it really just shifts it into the other log. Okay, properties of logs, it is the exponent. Remember from our expanding and condensing? So we could bring that up into the exponent. Now, if you have 2 logs subtracted, think about condensing. How do we put those back together? The arguments are subtracted. When we put them together, what do we do? This is where all those properties of logs are coming into play. Then, we can do our definition. So once the log is by itself, we change it to exponential form. 2 to the 5th equals x minus 1 cubed over 4. Two to the 5th is 32. Now what would you do? Well, multiply. Yeah, we have to get rid of the divided by 4. So if we multiply it over, okay, how do we get rid of a cube? Root of 128 equals x minus 1. And then final final step would be to add over the 1. So we get the cube root of 128 plus 1. Or if we are doing our decimal answer, it's a 6.0397. Or if you were going to 3 decimal places, I think that's what the Math Excel was asking for last night, 6.04 would be what it rounded to. And we just need a quick check. If we put in a 6 point something, 6 minus 1 is positive, so my arguments are positive. We don't have to worry about that. So it does work. Let's look at another one. Did everybody get that? Natural log x equals 9 minus the natural log of x squared. When I look, these two have a natural log. We are trying to isolate the log. That means we want a single log on one side. So what I'm going to do is add over the natural log of x squared. If these logs are added, how do we combine their arguments? Multiply. X times x squared would be x cubed. So then we can change it to exponential. We know a natural log is log base e. We get e to the 9 equals x cubed. Get rid of the cube, we cube root. You only need plus or minus if it's an even root. The cube root of e to the 9th, that's like 9 divided by 3, so you get e to the 6th power. That's your exact answer. If I ask for the decimal approximation, you can just type that in your calculator. And we can check. When we put those in, the arguments are positive, so it's okay. I'd like for you guys to try the next one. Excuse my error there. 9 divided by 3 is 3. So how about you did the third? Thank you. If logs are added, how do you condense them? Multiply. So we have to do x plus 7 times x plus 8. So we have to FOIL those. That's x squared plus 15x plus 56. Then, what do we do? Change it to exponential. So 2 to the first power equals x squared plus 15x plus 56. 2 to the first is just 2, so if you subtract that over, what multiplies to 54 and adds to 15? Right? Mm-hmm. So if we we set those equal to 0, we get negative 9 and negative 6. But remember at the end I tell you, you always need to check. What we are checking is that our arguments are positive. Negative 9 plus 7 is not a positive number. So negative 9 will not work. Negative 6 plus 7 is positive, negative 6 plus 8 is positive. So negative 6 is okay. That is the only answer we get. So all of those had logs on one side of the equation. Are there questions? Notice our strategy is to condense, so we have a single log, and then use the exponential form. The other situation we might have is when everything in the equation has a log. And so when I look at this, I see I have two terms. Both of them have logs in them. So while you could certainly try to get them together and then change to exponential, there's actually an easier option in this case. Because remember from yesterday, our properties. We said if each side has a log, you can drop that log. So if we can get it to be a single log with no coefficient on each side of the equation, we can drop it. So when I'm looking at this, my problem is the 2. I don't just want to divide it over because it just moves the problem to the other side. So what should I do with that 2? Change that into the exponent. At this point, now I have one log on each side. So the rule says you can drop that log and just set your arguments equal. To get rid of a square, we square root. Along with that, you have to do plus and minus. So you get x to be positive and negative 3. But when we check this, the argument has to be positive. If I put in a 3, that's fine, but can we have a negative 3? No. So 3 is the only answer that works. Why don't you guys try this one? So I have coefficients on both sides. Those both turn into exponents. At this point, I have a single log base 3 on each side, so we can drop it. X to 1/2, that means the square root of x. 2 squared is 4. How do you get rid of a square root? Square each side. Until we get 16. I saw a couple people added square roots on each side. That's 1/2 power is a square root. So to cancel it, you have to square. And then we just check when we put this in, our arguments have to be positive, and 16 is. So that answer works. Look at this one. We need, in order to use the property, it has to be one log on each side of the equal sign. So the fact that I have 2 logs subtracted right here is keeping me from dropping my log. But if those logs are subtracted, how do we put them together? So now you have one log on each side, which means you can drop it. So to solve, we have to multiply by the denominator to get rid of our fraction. Equals x squared, 4x and 6x would be 10x plus 24. If we subtract over the 24, get x squared plus 10x. What can you do with those? So if we set those equal to 0, we get 0 and negative 10. And we just have to verify our arguments have to be positive. 0 plus 4 is positive and 0 plus 6 is positive, so that's fine. Negative 10 plus 4, though, is a negative, so the negative 10 will not work. And 0 is our only solution. We're doing okay? I'm going to do one more like this, and we'll just do a few kind of bouncing back with everything we've done the past 2 days, and we'll be done for today. When I look at this one, I have 4 terms. All 4 terms have a log, so we just need to combine it so that we have one log on each side. On the left, if these logs are subtracted, how do we put them together? Divide. Okay, on the right, these logs are also subtracted, so I put them together by division. If you only have one log on each side, now you can drop it. What would you do now? Oh, come on. Somebody can tell me how to solve this equation. How do we get rid of our fractions? What can we do?
I would cross multiply. I don't know if that's right.
I think it is. So if I multiply those two, you have to FOIL, so you get x squared plus 3x and minus 1x would be plus 2x minus 3. If I multiply those, we get x squared minus 2x and plus 6x would be plus 4x minus 12. When I subtract my x squared, lucky for me, it cancels both of them, so I don't even have a quadratic anymore. So we just need x on one side and the numbers on the other. So we could subtract over the 4x, add over the 3, divide by negative 2, and x is 9/2. And then you just have to check if we put in 9/2, are all these positive? 9/2 is 4.5. 4.5 minus 1 plus 6 minus 2 plus 3. All of those are positive, so it does work. Any questions on these log problems? So what I want to do on the extra examples, I want to work through half of these today, and I'll do the other half tomorrow as a review. So let's just do, I'm going to do the right-hand side. So we'll do B, D, that side. So this one is a review from yesterday. if we are multiplying these bases, what do? Add. So 4x plus x minus 1, 5x minus 1. We cannot get a common base between e and 5. So our strategy from yesterday was to add a log. Typically we do just a log base 10, but on the problems with e's, I said it was nicer if you did a natural log. Because if you realize it, what happens when you have a natural log and an e? They cancel. Now if you don't, you carried on, that's fine. Your exponent comes down, you would just have 5x minus 1 times the natural log of e. But if you recognize that they cancel, it just makes your problem a little bit nicer. So then to get x by itself, we add the 1. And we divide the 5. So our answer is the natural log of 5 plus 1 over 5. To get a decimal in your calculator, make sure you do parentheses around the entire numerator. Also, every time you push the log button, it opens a parenthesis, so you have to close it. Or you can use that fraction feature so that you can see that you have everything correctly placed. You should get 0.5219. So that was from yesterday. Let's look at problem D. Are there any questions on this one? If I look at D, what would my strategy be on this one? Okay, so when we have those numbers in front, they come up as your exponents. So that's log base 2 of x cubed equals log base 2, 27. If it's just a negative, that's a negative 1. So now you can drop the logs. 27 to the negative 1 is the same as saying 1 over 27. How do we get rid of a cube? Cube root. Since it's an odd root, it doesn't get plus and minus. So the cube root of 1 is 1. Cube root of 27 is 3. And just a quick check, 1/3 makes my argument positive. So that answer works. Problem F. This one's different because these two have a log. The 1 does not. So we need to get our logs together. So we'll subtract over the log of x minus 2. If our logs are subtracted, how do we put them together? Properties of logs. This base is a 10. So if we change this into exponential form, we get 10 to the first power equals 2x plus 1 over x minus 2. If we multiply over the x minus 2, minus 20. Subtract our 2x, add over the 20, Quick check, when you put it in, your arguments are positive. So we're good. So I couldn't just drop the log from both sides because I had a term without it. If there's a term without the log, you have to change it to exponential form. Final example of the day. When I look at this one, we have 3 terms, but they all have a log. So if I can condense it so there's only 1 log on each side, we can just drop it. Over here, because these logs are added, when I put them together, we have to multiply. We distribute, that's 2x squared plus 4x. So now 1 log on each side, it can be dropped. Subtract over the 16. What can you take out of all of these, Brent?
2x.
Not the x.
R2.
Yeah. Okay. What multiplies to -8 and adds to +2? -2, +4. So if we set them equal to 0, the 2 out in front is never 0. We get +2 and -4. When we check, the argument can't be negative, so -4 doesn't work. 2 is our only answer. So there is a Math Excel open. Tomorrow we are going to do a few more review problems and then just have another day to practice.